Uh, oh, so many lights. Hello, everybody. So I'm Justas, and I will try to explain a bit more, like in simple words, that ship design is not so a big rocket science, let's say. So today, basically, I will try to represent our company, which is called Western Baltic Engineering, and to show how we see the ship design and the path into the future of designing the products. We are like from a big international shipyard company with more than 100 employees in the office. We are mostly working in new build projects, but supporting the yards for retrofit installation and new equipment installation or steel construction modification of existing vessels. It's quite a big part of our daily lives. And we are doing that already 20 years. Well, to break down what we are doing, for retrofit projects, we are digitalizing the existing vessels to be capable for engineers to work on computers. So we are transferring the real stuff into the digital area. We are working on, of course, for the conceptual design, for new builds, for detail design engineering, and mostly we are concentrating on ships like fishing vessels, cargo, special purpose ships, inland water crafts, and so on. Of course, having such a big team, the management part is quite a regular routine as well in our office, and if it's necessary, we are always ready to provide on-site technical support for our customers. Also today I would like to present some most recent design projects which we done. So first of all would be a green cargo vessel, which is supposed to be as green as it can be by installing a lot of, let's say, high efficiency equipment inside of the hull and outside of it. One of my favorite things is not very common used gate rudder. So this is quite relatively new stuff for the ship. So this is the device which is helping of course, to steer the vessel, to handle it, and reduce the environment impact by reducing vibrations and noise, and those kind of stuff also comes into reducing the power requirement. So we are reducing the emissions as well by implementing only one of the essential equipment for the ship steering. But probably the most interesting part for this vessel is the modular power plant, which is basically a containerized solution for, let's say, diesel generator, or it can be replaced immediately by just like plug and play and change that container to container packed with full of batteries or hydrogen fuel cells and similar like that. Another project where we developed is electrical pusher boat. It's perfectly suited for inland waters due to its very low draft, also quite long range with the capacity by pushing or towing approximately 2,000 tons. So our estimations is approximately 5.6 thousand tons of CO2 annually. That means like replacing about 10,000 normal road-going trucks. Okay, just come back. And one of the standout feature of this pusher is height adjustable wheelhouse. Very good if you have very low bridges. So, yeah. Another electrical project vision based basically for our Klaipėda port infrastructure, but it's highly adaptable for any customer needs. So it's a full electrical passenger ferry carrying up to 300 people with quite long battery service life. So the ferry could be recharged during the low peak power of the electrical power grid. So, yeah. So I would like to break down our internal processes, services, what we are doing for improvement of the design itself. So when it comes to ship itself, it's have to start from somewhere. It starts from the hull shape. This is very important stuff. Always comes from the client's main performance figures. So with the computer softwares, we create initial shape, then run through the simulation, going back and trying to find the best solution for the held, let's say, milestones or performance figures which we try to achieve. So, and in conclusion, if you put a lot of effort and create a really good ship hull, it could save up to 10% of fuel efficient, and it will reduce the costs of the ship lifespan. Yeah. That's a picture what we are doing like in office. So this is the picture in action what the engineer sees. So basically, after the hull shape is created with one software, then it transfers to another for simulating, for trying to figure out what the performance figures gives this hull. And we are performing the resistance tests, seakeeping analysis, or other motion response figures what we want to try to find out. And all of that is done by using CFD. And another example by using CFD and improving of ship hull efficiency could be designing some appendices of the hull. In this specific case, it is a duct which is helping to equalize the flow into propeller. So this not only gives the better performance, lower consumptions, and reduced emissions, but also it gives better impact to the environment regarding the vibrations and noise. And one of the last thing when it comes to the improving the hull or working with it, it's the analyzing the best suited trim angles with the various loading conditions at various speeds. So by having these guidelines, it's very let's say, good, cost-efficient solution for the clients to be more efficient in their daily life operations. Yeah, and talking about the sustainability, we always, at the moment, focusing mostly on decarbonization of ship power plants. We follow the technological development, all rules, legislations, and so on. Basically, all the key features which can affect our future ship design, which is very important for us to be competent in things what we are doing and researching and developing. Talking about research and development, one of our colleagues made a really interesting study where we took statistical data from all over the world for the tugs. Actually, the engine loads for tug operations, and he took an existing tugboat operating in Klaipėda port, which has a diesel engine, and that the existing one has the actual data, which is, do I have laser? It's over here. And that shows that basically most of the time, 90%, almost 90% of the time, the tugs are working like in very low engine load conditions. And having this, we modeled approximate emissions, and we did a comparison test for the same tugboat with the same conditions, but changing the, let's say, more environmentally friendly engine for, we swapped like diesel engine to the dual fuel, and this gives 10% of CO2 reduction. Sulfur reduction it's quite significant, 90%, and nitrogen oxides reduced by 65%. And talking about the nitrogen, this is probably the most interesting stuff from the study. What we found out that basically the existing tug engines, or in this particular case, this Caterpillar, it's under the Tier 2 and it's certified as Tier 2 engine. But reality shows that it's polluting more because the regulation, this ISO 8178, gives the testing procedures such as more suitable for regular vessels which are having, like, let's say, steady nominal engine speed. But as the study showed, that the tugs are working not in that range, working in very low engine power consumption, and this gives 25% more than its stated or its allowable emissions for nitrogen oxide. Yeah, so having this in mind, we are aware that in the future it might be some changes for vessels operating in the ports. So basically that was what I wanted to say today. And if still some ship design looks like rocket science, if you have questions, please ask. No. Thank you.